Chapter 6, Section 4 discusses intermolecular forces. So far, the forces we've talked about have been intramolecular forces, ones that allow individual atoms to be bonded together into a molecule. Intermolecular forces refer to the attraction that can be between molecules. So essentially, without these intermolecular forces, all covalent substances would be gases because there aren't any charges to help things cling together. Intermolecular forces are going to be weaker than the intramolecular forces, especially the ionic forces, which means that they're going to be easier to break apart. One type of intermolecular force is called a dipole force, and that's the force that occurs between the positive and negative ends of polar molecules. So such as in this diagram here, we've got some water molecules. You can, if you recall, the oxygen has a partial negative and the hydrogens have partial positive. So hydrogens of one molecule will be attracted to the oxygens of another water molecule, and so on, and that'll help to allow the water particles to cling to one another. Now, a type of dipole force is called a hydrogen bond, which obviously involves hydrogen, and it's going to be a strong dipole force that involves the hydrogen being bonded to something that is very electronegative. In general, the most common ones that form hydrogen bonds are nitrogen, oxygen, and fluorine. The rest of the halogens may be involved as well, being that they are also relatively electronegative, but nitrogen, oxygen, and fluorine are just the most common. And then finally, London forces, or London dispersion forces, are going to be dipole forces as well, but these ones are weak. They are actually an attraction between the atoms and molecules that are caused by an instantaneous dipole. And because it's instantaneous, or only for this split moment in time, these are going to be the weakest of those forces. So for instance, in this diagram here, this is showing a helium atom. Now, helium has 2 electrons, and these electrons are constantly moving throughout their electron cloud. Now, if by chance these 2 electrons end up on the same side of the atom at the same time, that's going to cause an instantaneous dipole, where this side of the atom is partially negative, and the other side then would be partially positive. Now, because of those partial charges, that's going to cause any other atom that is surrounding this helium atom to also form a dipole. So if this is positive, then it's going to cause this next atom's electrons to pull towards it. So the negative side would come out, which would cause the other side to be positive, and so on. So it can be induced within other atoms that surround that particular atom.